Right, question 9. Second last question. A car moves with the velocity of 2 meters per second, collides with another car, which is this one. Both has the same mass, and then the second car is initially at rest, so this one is initially at rest. After the collision, both car moves at 60 and 40 degree. I think what they forgot to write respectively. So what it said is VA would be going 60 degree from the horizontal, while the second car, which is VB, is 40 degree from the horizontal. Okay, and then you have to find the final velocity of each car after the collision, assuming the collision is elastic. Right, so this is the situation. So what we can do is we have to look at both the y and x component. Okay, so the formula that we will be using is the conservation of linear momentum, because for any types of collision, the total momentum will be conserved. Okay, so for x component, I'm just gonna write x component. Okay, so for x component, initially Sumwani moves at a horizontal line, so initial, just the usual MA UA plus MB UB equal to, now we have y and x component. So what we do is we are gonna resolve this. So MA VA, resolve this into x direction. We have the angle at the horizontal component, so we are gonna use cos theta A, and then plus MB VB cos theta B. Okay, sekarang both are pointing to the right, so it's gonna be positive. And then now MAUA, just substitute the values. MA is, okay, forgot to say, MA and MB is equal, so what you can do is you can cancel them, so it would make our calculation very easy, much easier. Okay, so UA is 2 plus UB is stationary, so 0, equal to VA, what we are trying to look for, cos 60 degree, plus VB is what we are trying to calculate as well, cos 40 degree. Okay, since there are two unknowns, we have to use two equations. We have to create two equations. Okay, so we can let this equal to VB equal to so 2 minus cos 60 degree over cos 40 degree. Wait, I think it's missing something. Okay, so let's try that without me looking at the answer scheme. So we are trying to let VB equal to all this. Okay, so VB cos 40 degree equal to VA cos 60 degree. So this one should be 2 minus VA cos 60 degree. So VB, yeah, the answer scheme was missing VA. Okay, so 2 minus VA cos 60 degree over dengan cos 40 degree. So this is our equation 1. Okay, now we can look at the y component. Okay, so for the y component, I'm just gonna continue writing MA juga lah, walaupun dia 0, MBUB, but now it is going at a straight line, so there will be no y component actually. Okay, but I'll equate that as 0 later on. So MAVA, we are using sine 60 degree, and then minus MBVB sine 40 degree. Why am I using minus? Because the VB is pointing downwards when we are resolving it at the y-axis here. Okay, so this one would be equal to 0 because the before collision all are moving at a straight line. Okay, now MA is MA you can just cancelled. This is cancelled. Then we have VA, which is we don't have yet, so we are left with this sine 40 degree. So we can equate this equation as VB sine 40 degree equal to VA sine 60 degree. Okay, so we can let VB again VA sine 60 degree over dengan sine 40 degree. So this is our second equation. So we can substitute equation 1 into equation 2. Right, so what do we have? We have 2 minus VA cos 60 degree over cos 40 degree equal to VA sine 60 degree over lagi dengan sine 40 degree. Okay, now do we have a single unknown in this equation? Yes, we only have single unknown, so we can calculate this. So VA is what we are trying to calculate. So rearrange sendiri je lah kan, boleh kan? So after you rearrange and substitute, you should be getting 1.305 meter per second as the final velocity for car A. And then we can then substitute VA into equation 2 to get the final velocity for car B. So VA sine 60 degree over dengan sine 40 degree. You'll then get the final velocity for car B to be 1.758 meter per second. Okay, so that is how you calculate or how you solve question 9 when there's x and y component. So always try to remember that if there's two unknowns, such as this, we have to find the VA and VB. We always need to use two equations. We have to do substitution in order for us to obtain the values. Right, so that is our question number 9.